What is data science? It is an interdisciplinary field. It is an interdisciplinary field. What do you mean by interdisciplinary field? If you look at this Venn diagram on the right side, right? If you look at this one, we can quickly make out that data science. So data science is at the intersection of all these things, right? It is at the intersection of statistical research, data processing, computer science, programming, okay, programming and mathematics, machine learning, domain expertise. As a successful data scientist, typically, right, you must possess a combination of mathematics and statistical. You must possess these skill set, okay, mathematical and statistical understanding and programming skills, the computer science proficiency and domain expertise to effectively analyze and derive the inside data, right? You need to pre-process it. You need to be good in all these things. Data science encompasses all these things, right? You should be good in mathematics, statistics, and you should be knowing programming. You should be knowing machine learning algorithm. You should be good in the domain also. For example, you are working in insurance domain or healthcare domain, or you are working in telecom domain. Okay, you should be knowing that well, so that you can come up with the actionable, recommendations. Okay. It is an amalgamation of many skill set. Okay, that is what your data science. And you can see these are the lingos that are floating in the internet regarding the artificial intelligence, right? Somewhere you can see in the net artificial intelligence, and somewhere you can see machine learning and deep learning, predictive analytics, computer vision, generative AI. Now generative AI is gaining a lot of momentum, and now explainable AI. Now this is also another advanced topic, an NLP. Okay, these are the different terms. You can see it in the internet, but what all these terms are all about? Are these terms are same? Are they different? Are they different? First of all, what is an artificial intelligence? What the idea of artificial intelligence is, in simple term, in the past, the scientists, they thought, can we give brain to the systems so that without human intervention, the system itself can make decision on its own, rather than writing the program and behave as per the programmable way. Let's give the brain to the system. How many of you watched the Rajini's robot movie, something, I forgot the movie name, Rajinikanth's movie, right? He gives the brain to the robot. The same thing here, the artificial intelligence. The whole idea of this one is give the brain to the system. The classic example is self-driving car. All you need to do is just hop into the vehicle, the car, and you can tell the car, hey, take me to the Siriseri IT park. Let's say you are in Adyar in Chennai, and if you tell the car, hey, take me to Siriseri IT park, that's it. You can sleep. The car will take you there. Once you reach your destination, it will alert you, hey, you reached your destination. That's it. You need to get down from the vehicle and you need to tell the car, hey, go and park in the so-and-so place. It will go and park it on its own, right? How it is possible? It is because of the artificial. They have given the brain to the car in the form of machine learning algorithms. Everything is mathematics now. Okay. So the idea of artificial intelligence is to enable the system to make the predictions, make the decisions on its own without any human interaction. That is what your artificial intelligence is all about. Then what is this machine learning is all about? Machine learning is a subset of artificial intelligence. Deep learning is also a subset of artificial intelligence. Computer vision, natural language processing, generative AI, explainable AI, all these things are the subset of the artificial intelligence. Artificial intelligence is an umbrella term. In college, you say, I'm a B.Tech student. right? This is an umbrella term. So BTech, you tell me which stream you have taken. You are a computer science student, or you are the ECE or mechatronics. Which branch you have taken as part of BTech? This is umbrella term. Similarly, artificial is an umbrella term. The rest of the things are falling under this umbrella term called artificial intelligence. Now the generative AI gained a lot of momentum, even explainable AI, right? Even this one made a major breakthrough. Which one? The explainable AI. Okay, what is machine learning? Machine learning is nothing but you are training the system with the historical data, and then you apply the trained algorithm on the unseen data to make a prediction. That's all. For example, you are a student, right? I'll show you, let's say you are a kid, you are a small baby, or let's say you are a 5-year-old kid or 3-year-old baby. If I show you a toy, the elephant toy and giraffe toy, let's say you just assume that you are 2.5-year-old. And if I teach you, right, hey, this toy is elephant and this toy is giraffe. The kids' mind, right? Kids are so smart, right? They will understand everything. Oh, this toy is elephant and this toy is giraffe. You're showing the toy, and then you are labeling that toy with some name, right? The elephant toy, you're showing it to the kid, and you are telling that this is an elephant. The elephant is a label. Giraffe toy, you are showing it to your kid, and you are giving the label, you are labeling it as, hey, this is a giraffe text. This you have done it with a 2.5-year or 2.5-year-old kid. Let's after 6 months, you visit the kid with slightly different posture of the same animal's toys. When you show it, let's this time the elephant is lying on the floor, and the giraffe is also lying on the floor. And if you show the toy, and if you ask the kid will say correctly, right? Hey, this is elephant, this is toy. How it is possible? Because you train the kid with that data. Same way machine learning algorithm works. For the machine learning algorithm to make a prediction, you need to train the algorithm with the data. Like how you trained your kid, hey, this toy is called so-and-so thing, right? But again, you show the different posture of the animals, the same animals lying on the floor, and both animals, the elephant and giraffe. Still the kid can say, hey, this is elephant, this is giraffe. How it can tell? It is not memorizing it, right? The kid is not only storing the shape, it stores the shape of the toy in its brain along with that label. See, this is your giraffe. Bear with my drawing skills. This is your giraffe, right? Assume that this is your giraffe, okay? This is giraffe, you show it. But this giraffe is in standing posture, and the next time when you go there, you show this same giraffe, but this time it is in the sitting posture. Okay, this is sitting and this is standing posture. But you tell the kid, hey, this is the toy, and for the giraffe, giraffe, okay, this is called your label. This is your data. Okay, you show the kid with that data and then the label, input and then output, input and output. And the very next day, if you go and show the same thing, it will tell clearly, right? Yeah, this is giraffe and this is elephant, it will tell. Because yesterday you taught the kid, right? And after 6 months or after a few days, when you go back to the kid and the same toys, when you show it with the, let's say this time that, the giraffe is sitting on the floor and the elephant is also lying on the floor. And if you show it, still it can tell very clearly. The kid is not, in that case, you will understand very clearly, the kid is not memorizing it. Only when the elephant stands and giraffe stands, that is called elephant and giraffe, it will not think that way, right? That means it stores the pattern. Hey, the neck is longer. Those animals have the longer neck. That is giraffe. That is the pattern. Those animals' neck is longer. That is the pattern, right? And those animals' ear is bigger. That is elephant. And if it has a trunk, it stores these patterns in its brain along with the label. According to us, what we think is it memorizes it. The kids are not memorizing it in this case. You try it out with some kids. Even I tried this with some kids. They can tell still very clearly, no, this is elephant, this is giraffe. Clearly they'll say. Likewise, machine learning algorithm, you need to give the input along with the output label. Right? You need to tell them, hey, these are the inputs and output, you take it. For this, the output should be giraffe. If you see any animal like this, you need to tell, hey, this is giraffe. With this shape, you need to tell giraffe. You train the algorithm with the data, input data and label. Once you train the algorithm, when you apply it on, when you show, right, let's say you train this with these images and with the labels, later point time when you show some other image, let's say this time you are showing an African elephant, still your algorithm will tell, hey, this is an elephant. You need to train your algorithm with huge number of data. Okay. So what is the definition for machine learning? Machine learning, don't worry, anyhow, I'm going to repeat it. Later point in time also, I'm going to repeat it. Machine learning is nothing but training your algorithms with the historical data. And then you apply this trained data, trained model on the unseen data. What do you mean by unseen data? This time you are going to show a different, what is that? A different breed of elephant, right? Earlier you have shown the American elephant. This time you are showing African elephant. But still, it can tell, your model should tell this is elephant, right? You should tell. So for that, you need to train your algorithm with huge volume of the data. So the definition is train your machine learning model with the historical data. And then you apply this trained model on the unseen data, like the African elephant, you did not see it, right? Still, your model will correctly predict and says, hey, this is the elephant. Because the machine learning model learn the pattern, like how a kid learn the pattern. Longer neck is giraffe. It learns the pattern. It is not memorizing it. The deep learning is, deep learning got evolved from your machine learning. We have something called neural network algorithm in machine learning. What they did, they came up with some kind of breakthrough in terms of improving the traditional neural network. Okay, they developed something called convolutional neural network, recurrent neural network. Likewise, convolutional neural network, mask RCNN, and mask RCNN, fast RCNN, faster RCNN. Likewise, they made some breakthrough to the typical neural network, right? They made some breakthrough by introducing different layers. In simple terms, the deep learning algorithms evolved from machine learning. It's something like Windows, how they release new versions, right? So this is an older version, this is slightly higher version. It got evolved from here. For example, you wanted to do image classification. With a deep learning algorithm, you can do the image classification with a higher accuracy. Okay. Why accuracy is important? For example, MRI scan. You are taking MRI scan, brain and lung during COVID time. Most of the patients, they underwent MRI scan to the lung. Instead of human, right? Give it to the algorithm. These algorithms were trained by various lung scans. Okay, and all the issues, everything. Now your algorithm, deep learning algorithm, right? It can make an accurate prediction saying that, hey, this guy has a tumor. Or is a malign tumor or benign tumor. Benign tumor, even though you have some lump, it will not cause any problem. If it is a malign, it's a cancerous thing. If the algorithm wrongly classify a person who has a benign cancer as a malign cancer, what will happen? What will happen? Next one is the natural language processing. It is, slightly different from other algorithms, but even in the case of natural language processing, we use the deep learning algorithm like RNN, recurrent neural network, using which you can predict the next word prediction. The Google, when you go and type, what is deep learning, right? You can give me the top 10 deep learning algorithm. When you type top 10 deep space learning, automatically display the next word as the algorithm, automatically displays the next word, right? It is all possible because of the deep learning algorithms. Even in the case of NLP, we are using deep learning algorithms in some cases, okay? And next one is the generative AI. Even the generative AI is a specific subfield of your artificial intelligence. It focuses on generating new content of data rather than analyzing or interpreting your existing data. Which one? The generative. As the name suggests, it generates the content. Okay. For example, you want to create images. That is possible. It can create the images. You can create the images. If you want to create the text, you can create the text. If you want to create the music, if you want to create a video, that is also possible. All you need to just type the text. There are some apps, right? What it does is, based on the text you typed it generates the production quality images. We have something like DALI. How many of you heard about DALI 2? DALI 2 is, very popular now, right? And there are other applications also available to do the image generation. Just type the text, it generates. There are some applications, just type the content, the thing, right? You type, for example, you are selling coffee powder, right? You want to write an ad content. Please write an ad content for selling my coffee product. It generates the content, text automatically. There are applications, create an ad content for my coffee product. In that case, it generates the video itself. It is all because of the advancements they made in the artificial, is called the generative AI. Okay. Now the question is, what is the difference between AI and generative AI? The traditional artificial intelligence algorithm, right? Using which you can make predictions. For example, I want to classify the images. Given the image, you classify whether it's an elephant or giraffe. It classifies it and it makes the predictions. Which persons are more likely to develop heart attack, or which persons are more likely to default the loan. That is what the traditional artificial intelligence techniques does. Whereas in the case of generative AI, it is focused more on creating the new content or the data that is somewhat similar to what it has learned from the existing data. Okay, that is what your generative. So as the name says, generates the content, images, videos, text, whatever you want, you can use it. And the next one is the explainable AI. Well, what is explainable AI? Anybody has any? This is also gaining a lot of momentum now. Okay, they made a significant breakthrough even in the case of explainable AI. Anybody has any idea? So in the case of the difference between artificial intelligence, the traditional artificial explainable AI is, like I said earlier, the artificial intelligence can make a prediction, or it can classify the given any image, whether it's a dog or cat or giraffe or elephant. You give some input and then it produces the output. It's kind of a black box. I have given this image as an input, or I have shown this image to the algorithm. It predicted or it classified and saying that, hey, this is elephant, this is giraffe. It gives me the text. If I show any image, it gives me the text. But what is happening behind the scene, we do not know. Okay, whereas in the case of this one, right? So in the case of AI, there is a lack of transparency. That is a problem. Okay, there is what is happening in between, how it tells it's an elephant or giraffe. Is there any way it can, it can justify how it came up with this decision of or predicted outcome label as elephant or giraffe? Okay. It's something like, let's say you are a student, right? If I ask my algorithm to predict whether you will pass the exam or not, if it says simply you will pass, fine. But how did you predict? Is there any way you can explain what factors can help me to, on what basis you predicted that I'm going to pass? That is where the explainable AI comes into picture. Okay. It predicts whether you pass or fail on an exam based on your past performance and study habits and other factors. Okay, but in the case of traditional AI, artificial intelligence, there is no transparency. Okay, but in the case of explainable AI, as the name suggests, right, it gives you the explanation. With that explanation, you can understand the reasoning behind the artificial intelligence algorithm decision, whether you pass or not. What is the reason behind it? Can you tell me that? What are the steps involved? The explainable AI will tell you. Okay. And even within NLP, now the transformer model, autoencoder, variational attention models. Likewise, a lot of algorithms came into picture. ChatGPT is an OpenAI's product. And what is that? What are the other things? The NLG, natural language generation. Okay, let's say you want the ChatGPT to generate the article. It generates it. Please write a blog on artificial intelligence. Please write a blog on explainable AI. It generates the natural language understanding, natural language generation, all these many things. Chatbot, you can create a chatbot. Everything is possible here. Okay. And the explainable AI, the products, I don't know how many for Google Cloud explainable AI, the Microsoft Interpret is Selden Alibi. These are the products that are powered by explainable AI. So we have something called Selden Alibi. Okay. So it is an open source library. Okay. And so it includes some algorithms for model explanation and adversarial detection and so on. Okay. And we have something called S2O.ai. You might have heard about S2O.ai, right? So those of you already explored this one. Okay. And these are even IBM Watson open scale. Likewise, many things are there. Anyhow, I will explain you these things later, okay? And it's too early to discuss so many things in the very first session. You will get overwhelmed, okay? Next one is the computer vision. With computer vision, you can do image classification, image segmentation, and object detection, right? Object detection, image segmentation, image classification, everything you can do it with computer vision. Even the computer is a subfield of your artificial intelligence. For example, what is object detection? If you have multiple objects in a image, right? Here you have one image, your cat, dog, everything is there, right? So what in the case of object, it goes and detects what are the objects are there in this image. It draws the bounding box around it. Okay. In the case of traffic, right? You in the traffic, the road, when you go to the road, and if you take the photo and if you give it to the algorithm, it draws the bounding box around each and every image, right? Objects, the car and the track, it draws the bounding box around those things. Okay. And supposing some images, right, which you can't see it, it can draw the bounding box. In that way, you can go and check what this object is all about, right? So even in the case of COVID, during the COVID time, they've used this kind of algorithm, object detection and all. So which people in the public are not wearing the mask, which people are wearing the mask, right? It draws the bounding box around the people. And the red colored one tells us, hey, this guy is not wearing the mask, and these guys are not maintaining the distance, right? So these are the applications, computer vision, and even deep learning applications are, the lot of applications are there when it comes to deep learning. The self-driving car, right? In the case of self-driving car, it does the image classification, whether the traffic light is red or green or amber. If it is a red, the car has to stop. The self-driving car, in that case, they use the CNN algorithm, convolutional network. So what it does is, when the car approaches the signal, if the signal light is green, it automatically detects, it automatically, so if it is a red color, it stops it, right? See, in the case of artificial intelligence, the scientists, they want to give the brain to the system, like car, okay? Giving the brain alone not sufficient. Eyes are required, right? For a car, it needs an eyes to see who is coming in front of it, who is driving alongside of the car, who is crossing the road. Only when it has an eyes, it can act accordingly, isn't it? That is where, see what they did, right? Scientists, okay, giving the brain to the system alone not sufficient. They go one step further. They went one step further and decided, is there any way we can give the vision to the systems? Car. Can I give an eyes to car? That is when the computer vision came into picture. Now the cars are bombarded with a lot of sensors. Those sensors gather the external world thing in real time. Okay, everything is happening real time. Okay, so it does the classification, everything in real time. Hey, the red color is there. You can stop. We'll have to prepare to stop the car. Somebody crosses the road. Hey, there is some object is crossing the road. Slow down the vehicle. Without driver's intervention, everything is taken care of automatically because of the artificial and computer vision and so on. Okay. Okay, it is already late. Sorry, Pavitra and Raji and Swarna. Okay, you wanted to leave a little early, right? Fine. I'm going to wrap up the session now. We will get back to about the next session in a day or two. Okay. Do you have any questions so far? The topics, whatever I covered so far. Do you have any questions? Guys, don't